Thank you, everybody. Welcome to this session on LLMs and RAGs, which happens to be the most happening topic in the AI world currently, especially the generative AI. We come up with interesting topics as free webinars almost every month. So this is our topic for October, and some of you, I can see, repeating and coming back again. So it's great to see repeat folks. Today's topic will be more focused on the RAGs part of it. We had some discussions and points on the LLMs before already. Before we get started, I just want to take a moment and talk about our company, bigdatatrunk, and give several interesting resources which will be more practical from your perspective. So bigdatatrunk in one or two liners is a professional training services company based out in California. So most of our team is instructors and everybody in California. We focus on B2B training, corporate trainings mostly. Fortunate to be teaching Fortune 500 companies, Fortune 100 companies in live instructor-led trainings on various technologies, main of that being data and AI. That's our forte. 1/3 of our catalog is focused on data and AI, and right from the beginning, we have been focused on data, but we do several other technologies, including soft skills and boot camps and upskilling for companies. There is an element of e-learning which anybody can join, public can join as well, B2C, and so on and so forth. We have over 300 plus catalog items, almost reaching 400, and been fortunate to serve hundreds of thousands of students, and very happy to share our journey with lots of different people and transforming several lives through that path. On our website, you can find a lot of useful and free resources as well. So if you go to the resources section, you could get some free resources, trainings. So if you are interested in developing a career and may not have the funds or kind of things, especially the economy and with all the layoffs and unfortunate things happening, we put together several free trainings. These are curated resources, some by us, some by external sources, but we just wanted to make that available on several technology skills, machine learning, Tableau, Linux, all these different areas which you can, mainly the core foundational skills which you're trying to get in. So I think all these resources are going to be free. So you can just go to resources and the free training page and you'll find that. We also have put together several interview questions if you're trying to really prepare for an interview and job kind of a thing. Several of the technology questions we have put interviews so you can practice and prepare for that. We run communities of meetup groups where we share free content. And these are several meetup groups which we have partnered with Google, partnered with Microsoft, and several informal ones like the ones we have for interview prep and several other things which we used to do a lot of interview prep focus, but now it's been a little generic but as well. So we have different meetup groups. You can again go back to resources and meetup. If you click, you will get that. All of our sessions are recorded and posted on my YouTube channel and also on this page. So if you go to resources again and go to webinar and videos, you would find all of our past recordings. They had the LLM session, generative AI. So we have been going through a generative AI theme in terms of demand, and accordingly, we have been catering that. But there are tons and tons of videos which are available. Not only these, but if you go to the actual YouTube video, this would take you to the channel. I'm just going to quickly click that, and it will take you to the YouTube channel where you can really try to really get this LLMs going. So, wow, it's interesting. So that's available for free. The next one which we have for November, we have is taking the next step in the journey of AI, which is responsible AI. As part of AI, you know there is a lot of challenges and known issues, and that's our goal in the next webinar. So if you're interested in joining that, I'll put all these links on the chat. So either you can directly go to bigdatatrunk website and through the resources and other links which I mentioned, or you could just take the links which I will be posting in the chat in a little bit. But we have our next one, which is scheduled. There is a meetup group you can join from there, or you can go through Eventbrite. Either places it's going to be free. It's coming up on the next month, 28th of November, Eastern time, 8:30, Pacific 5:30, similar time what we have currently. And glad to see a lot of repeat customers. That's what Eventbrite is telling us, but this shows the quality and kind of success which we had by sharing and nurturing the community. So that's what it is available. If you feel inclined and some of these things find interesting and you want to take the journey forward, there are e-learning options. So again, going back to the main site, you could just go to offerings and e-learnings, and there is a very packaged e-learning on demand, very economically priced offerings which are available. There are some free trainings, very high quality ChatGPT trainings. If you're just getting started with ChatGPT, or even if you believe you have ChatGPT, I would strongly encourage you all to try this training, and I'm 100% positive that you will feel like, wow, this is a different approach to ChatGPT and learning kind of a thing. So try that free course if you would like to, or you could try a free trial by going to any of the courses which you may be interested. And then there's a free trial which you can take for 7 days. It's very economically, almost like few coffees worth of things which you can take per month, or a yearly package of $100. You can cancel at any point of time, even say in 7 days, and end it. It's your choice. The best thing in our e-learning things is more, which I call as tutorials. A lot of people know things and want to practice and continue the journey. And that's where the tutorials come in handy, where you really get some hands-on experience and actual stuff which you can practice and continue building your knowledge. We just wanted to share those resources. I'll be sharing those links so that you can utilize as per your need. With that said, I think we're going to switch back to the topic. So today's topic is, as I said, LLMs and RAGs. And our speaker for today is Aparna. She has been leading this series of generative AI. She was doing the LLM part last time. Very knowledgeable in the AI space, works and teaches for a lot of Fortune 100 companies in the generative AI space. She has working on a PhD and has been professor in academic area. So wealth of knowledge and experience which she brings, and humble enough and kind enough to share with the world. So with that introduction, and I welcome Aparna, and over to you.
Thank you so much, Raj. Again, good evening or good morning, everybody, based on where you're joining us. Welcome to this session. So let me share screen and get started. Okay. All right. So welcome to today's topic, retrieval augmented generation, RAG. I'd say, a little technical perspective, but also kind of beginning of mostly with slightly general purpose, non-technical use cases, so that we even understand, like in the very first place, why we need to be looking at this topic or understanding it. Obviously, like Raj has mentioned, very much in the AI space right now. Any LinkedIn group you pick up, or any recent AI-based article that you read, there are at least these new terms that are popping up all of a sudden. RAGs have been actually around for a few years now, although they have like really picked up in steam, I would say, over the past couple of years. We now have, a lot of talk about agentic AI. We have large multimodal models, LLMs, also coming up. Just recently, I've also heard a lot of talk about large action models probably going to be like, the next big thing. So I guess, all of us agree there is way too much happening at a very fast pace, especially in the generative AI space. So always helps to kind of keep abreast of what is happening, and exactly, the reason for a lot of these new interesting developments coming up. In terms of what we'll be exploring probably over the next 45 minutes, we are definitely going to be doing, I would say, like, a 10 minutes worth of discussion on LLMs. Again, thanks, some of you have been here, in fact, for our previous webinar where we were talking about foundations of LLMs. But having a good understanding of exactly what an LLM is, how it works, and also what are certain well-known limitations. I think, that is one area probably that most of us would agree on. We are seeing certain areas where maybe they do not function, as promised as such. So we definitely need to be understanding those limitations before we can go ahead and talk of various different kinds of solutions for that. And that is where, RAG comes in. At least a couple of very well-known limitations of LLMs can be handled very, very effectively with retrieval augmented generation. So we'll try and understand how that works at a high level. We'll look at a few use cases and also see, how they both kind of integrate together. So that would be like our plan for the next 40-45 minutes. Okay. Again, LLMs, I'm sure probably there's hardly anybody out there now who doesn't use it in some form or fashion. It could either be those free variants that are out there that we maybe use like on a personal basis. A lot of us, irrespective of the kind of organization, the scale of organization, most of us do have access maybe to more proprietary or enterprise level subscriptions of a lot of these models. We also see especially organizations being a little jittery sometimes about giving access to probably some of these LLM models, especially that whole fear around one, anything that you put into the system itself kind of becomes part of a much larger training data set. And then the second issue, obviously, being accuracy. They have been known to make mistakes. Even personal experience, those of you who have actually seen something like that, if you could you could also share that in the chat. Almost all of us having seen at least a few instances where sometimes these LLMs get even like the most basic of things wrong. But before we get there, generally any general purpose large language model, they've obviously been trained on vast amounts of text data, pretty much all the data available on the internet. It could be coming from all these websites like Wikipedia, all the online resources available out there. Not even thousands, probably millions and millions of books worth of data that these models have actually gone through, thoroughly understood, and then are able to generate almost so-called human language, kind of respond back to us exactly in the same sense, in the same tone that we are going to be asking questions or putting in our prompts. We are probably using them for like pretty much all the tasks under the sky as of now. Writing, summarizing, they were like maybe initial ideas compared to what we are using them for now. This is interesting. One of the latest security reports that came out with ChatGPT 4.0 advanced, they say now people are in fact developing almost like an emotional bonding with ChatGPT. And yeah, they're kind of warning against it because people are like getting so used to probably using a lot of these technologies. They're to a certain extent almost replacing human connection in some form. One aspect where that whole term large comes in, they have been one trained on very, very massive amounts of text. The other reason why we usually attribute that term large is because the models themselves, the internal neural architectures that make up these models, involve billions and billions of parameters. Again, a little, I would say, understanding of the essential transformer kinds of architectures that go into building these LLMs is a little necessary to appreciate this fact. But one of the earlier ChatGPT variants that we started off with, I would say probably back in 2020, maybe that model involved close to 100 million parameters, whereas some of the recent models that we are interacting with, the scale is almost at 5 to 700 billion parameters. The number of internal weights that these models have to learn and manipulate in order to be able to do that text generation task really well. So in terms of scope, they have improved massively. All sorts of diverse data sets, all sorts of languages that we can think of. And it is because of access to this very diverse and huge data set, which is the reason, why they are able to understand a lot of patterns, have access to a lot of world knowledge, so that depending exactly on the kind of query or prompt that we ask, they are able to recreate any sort of information that we are looking for. I'd say most of us pretty much have where it was like probably Google a couple of years back for any query that came up, like the first would reach out maybe to Google. Now I see most people in fact making use of either ChatGPT or Google Gemini, again depending on your personal choice. It could be Perplexity or it could be Claude. They've almost effectively replaced search engines for sure. they are obviously having like, a lot of applications across domains. Again, very few mentioned here. Any sort of chatbot, voice assistant, any kind of virtual assistant kind of support in all the customer support domains, content creation across the board, whether it is, even students for that matter looking for support in terms of assessments. It could be in terms of coming up with content for a lot of these SEO based marketing kind of tasks. Uh, Again, across the board, all sorts of content creation. The limit essentially is how well we are able to prompt, and how effectively we are able to actually show it or ask it what we are interested in. And to the most part, they do a great job of creating the exact kind of content that we are asking for. We have a lot of these AI assistants, or pair programmers as such, where again, the complexity or, the advance is essentially limited by how well we can prompt them. And you can ask, maybe, if you pick up like one of the more recent versions of, let's say, Copilot, entire applications can be now completely created only by making use of these Gen AI based kind of tools. A few key aspects, we will just go over each one very, very briefly. The reason this becomes necessary is, later on when we start talking about how RAG can be used to effectively augment a lot of this process, that this knowledge actually helps in understanding where exactly, the RAG kind of comes in. So the very first aspect, for any large language model, the minute you kind of put in whatever prompt that you're interested in, is tokenization. Again, comes from that whole NLP space where we are trying to break up our prompt into those, for lack of a better term, I'd say, all the individual words that actually make up your prompt. But what could be like, a word for us, not essentially all the time might translate into a token. A lot of times it could be broken up into much smaller portions, and each of those could become a token. Now, for example, the picture that you see on screen, where everything has been kind of color coded. So this is just Python, and then another line, the language Python, then one more where we have just, Python in capital. Again, probably the way we use it and the surrounding context, it could refer to a different word. Sometimes we could be talking about the programming language. Maybe in other contexts, we might be referring to snake. So depending again on the surrounding context, the way it is converted into some sort of a numerical fashion. That's the whole idea behind tokenization. So we take these long lines of text or strings, break them up into much smaller pieces that we kind of feed into the LLM. And again, any deep learning model, any NLP based model, whether it is image data or text or audio that you interact with, let's say Alexa, it has to be essentially converted into some numerical fashion, because that's the only kind of data that the systems understand at the end of the day. So once you've done the tokenization process, it has to be once again converted into this numerical fashion. There is this really interesting, website, like a live site, where you can put in your text, and then, it converts it into those numerical forms. So you can see how each word gets converted into its equivalent numerical form. I'll leave this link, or we'll take a look at it a little towards the end based on time. But yeah, this is like a very good visualization that, like in live form, converts your strings into those equivalent numerical patterns. Once we do have those individual tokens, but in a number form available to us, they need to be converted into some sort of a fixed dimensional vector. Again, I'd say much longer connected kind of pieces of, I'd say, maybe a easier way to think of it is some sort of a numerical representation, but much longer, which does try to capture a lot of aspects of each of those individual tokens, that we developed at that previous stage. So we are now talking about, generating word embeddings. Again, the whole topic of embeddings itself, something that we can go into very deep, very, very important aspect. Also, one of those very important initial stages that kind of determine how exactly your LLM handles your prompt and how it goes about creating a response. So now once we have our tokens, they are converted into these much longer vectorized representations. And while it is doing this, it is to kind of give the model a lot more contextual knowledge and a lot of surrounding world knowledge, I would say, about each of those terms that makes up your prompt. Now, for example, this is a simple English sentence. What is text embedding? And it is, once this sentence has been converted into that embedding fashion, into that vectorized fashion, this is the kind of representation that we come up with. Obviously, numbers probably that don't make much sense to us. Also, these are like really long. It could be anywhere between, there are some models that probably go for like a 700 plus length of embedding, to certain models that go to 4,000, and certain models that also reach like a 12 to 1600 length of vector representation of each of those words that make up your overall prompt as such. Now, this particular embedding that we see here has been created by OpenAI GPT-3 version. So again, depending on your choice of LLM, they could be making use of any of these various different embedding styles. There are some 7 to 8 really popular ones available out there. Google most often uses their own technology, but Facebook or Meta, they were using word to vec or fast text. Again, almost all of these LLMs have like a lot of variants available out there, and certain times it is also possible for us to go ahead and select like a slightly different embedding style within each of those models. Then the majority of work or improvement, or I would say, basically the whole functionality of the LLM comes from making use of attention-based mechanisms within the internal architecture itself. So that word attention, what does that mean? Any prompt that you put in, for that matter, maybe there are certain terms which are more important. Now, for example, if I put in a prompt, let's say, what's the temperature right now in California? So now is probably a very important word. Temperature happens to be a important word, and that whole relationship between temperature, California, and now, that is what that system has to really understand thoroughly for it to create a proper coherent kind of a response. So while it is parsing the entire input, or while it is taking a look at whatever embeddings that we have generated at the previous stage, there is some sort of weights. Okay, let's put this more simply. That entire prompt is kind of examined very thoroughly, and certain level of importance is actually given to each of those terms. So some terms obviously are going to be like a little more important than some other terms. So what this helps the model do is figure out which of those are like extremely important and which can probably be ignored, and those terms or words which do have a higher amount of attention actually allotted to them would become a little bit more important in terms of doing that whole query search and being able to pull out relevant information. So again, based on the output that it gets through this attention stage, it is going to allocate a slightly different amount of weight or importance to each of those words, and accordingly, that importance kind of goes into the whole querying and creating of the response itself. Also, almost all of these really good LLM models do make use of this self-attention mechanism, where every word in your prompt, with respect to all the other words that show up in your prompt, how relatively important or unimportant they are. Certain times, something that you see very later on, you might be trying to relate to a term that you had actually made part of your prompt much earlier. So even, within that string of terms that you're putting in to the LLM, which are relatively linked up to one another, probably, something that you need to work together. So these kind of, I'd say, some sort of uh, numerical weights are attached, also based on the positions at which each of those terms come up. So again, in terms of the math involved, there's like massive amounts of calculations that happen at the back end in terms of assigning these various different weights and being able to figure out which part of the prompt is extremely necessary while it is able to actually generate the response for us. Summarized very, very simply, in like, if we have to kind of capture all of that in one single statement, I would say what attention based mechanisms do is they try to figure out the significance of every single word within a given sentence, which word needs to be more significant than something else. Very, very, very important stage again, which also is kind of responsible for the whole power behind all of these LLMs. They're like capable of answering queries across the board, across any sort of a domain. That happens because they have been pre-trained already on huge amounts of textual data. Again, millions and millions of sources of data that they kind of pick up all over the internet. And this is what gives them that very general purpose capabilities. Your prompt one could be build me a recipe, prompt two could be give me a diet plan, prompt three could be write this code. You're just like limited by the creativity of your own prompts. It has been trained on such a wide variety of data and data sets that it will be able to understand and pretty much generate any kind of response back for you. And they do this in that whole pre-training stage where they have understood the syntax, they understand the semantics. How does, maybe supposing, you ask, write me a very formal email that I need to send out to a higher up in the organization, versus write me something that is very creative and informal that I'll probably put on an Instagram post. So in terms of context, in terms of grammar, in terms of the underlying semantics, based on what kind of environment, what kind of tone that you are interested in writing, it has seen all of those various variants already, massive numbers of those. So it is able to recreate exactly based on how you're going to prompt it. And it's this whole pre-training stage that actually gives it this capability of being able to understand a lot of general purpose language. One limitation though at this stage is, although it has like, a lot of broad knowledge per se, it doesn't have a lot of in-depth contextual knowledge, because it is kind of limited by the kind of training data set that it has been exposed to. A lot of times, again, think of it in terms of someone who has read quite a lot in a very broad sense. So they might be aware of a lot of different topics, versus someone who has probably worked in one single area, let's say for 20 years, lot of ongoing research on the same area, but going, more and more in depth over a long period of time. So while the first person might have like a lot of broad knowledge across a wide variety of areas, the second person would definitely have access to a lot more in-depth, deeper kind of knowledge, which you probably cannot expect from the first person. So this, I would say, would be the difference. LLMs have that broad variance of knowledge across domains. The in-depth part of it is very much determined, or in certain areas limited by the kind of training data sets that they have been already exposed to. The final aspect that kind of puts it all together when it comes to building an LLM, while they are pre-trained on those huge massive data sets, towards the very end, in terms of the actual implementation, we also use this whole concept of transfer learning, where you want them to be able to leverage their general purpose knowledge they have across the board, but then kind of customize it to the task at hand. So they might have been trained on 10 different domains, but if you ask like a fairly simple question from a slightly different domain, even though it is not a part of the data set that they have been trained on, because they are good at this general purpose knowledge to a certain extent, they will be able to apply that learning and create this new kind of output. So they are transferring the learning that they have done, maybe on one kind of really massive data set, taking those learnings and then being able to apply it across another area. Again, maybe not 100% accurate, but just to kind of use a metaphor to bring across that whole concept. Maybe someone who has really, let's say, good at driving a bicycle probably for 10 years, and they know how to like maintain their balance. You try to put them like on a much faster bike, they would be very easily able to take their previous learning or knowledge and then accommodate or probably adapt to this new situation, because they already know how to handle that whole balancing issue, and maybe that sense of direction and everything. So we're taking learning from one area and then using that to get better at some other area. And this is like the final thing that probably allows an LLM to be kind of functionally good at a lot of different things. The whole factor that allows it to adapt to a lot of different domains. We have obviously lots and lots of use cases. They're extremely good at text generation, any sort of text, formal, informal, short form, long form content. You can just upload huge amounts of text. It could be an entire document, a complete novel, a research paper. They're able to build these really good summaries for you. Again, you can say, just give me like a one paragraph summary, give me a one page summary based on your prompt. Most often they are able to create the exact kind of response that you're interested in. Almost across the board, any sort of platform, website, app that we interact with, probably all assistance at the very first stage is definitely being driven through LLM based agents. It's only once, if we kind of keep on and we don't get back a satisfactory response, that they are now transferring us to actual real agents as such. Code generation, sentiment analysis, translation is being done extremely well. Multiple languages, especially the more recent advanced versions, in real time, you get to pick your source and target languages like from a list of 50 to 60 options, and they're able to do that real time translation, and also in that spoken format extremely well. It started off with text based inputs, but now you can interact with it in the speech mode as well. Okay. Where do they not really kind of scale up, or certain areas where they are still probably failing? This is probably an aspect that maybe as an individual user, to a certain extent, I wouldn't really be bothered about the whole cost and the efficiency aspect to it, the amount of power it takes to actually run any of these queries, all those massive data centers of NVIDIA GPUs that these companies are maintaining and running. So the data processing, storage, and the computational aspects of it. Yeah, the second one is probably something that all of us definitely very concerned about, sometimes hurts us badly. The whole idea of LLMs hallucinating. Irrespective of the question, it sounds like they are creating a legible response for us, but they have been known to create responses that absolutely do not make sense, because a lot of times they do not say, I do not know this. They just go ahead and create some sort of response for you, and checking for the accuracy of the response is somehow still our responsibility. So across the board, again, all these LLMs, the more basic ones versus the advanced, everyone comes with that disclaimer that you are responsible for checking for the accuracy of the output itself. Again, depending on the training data set, if they have only been trained on data that probably is like a few months old, that also impacts the kind of accuracy or the correctness of the response that you get back. Again, this aspect is probably very, very, I'd say, pertinent to organizations. A lot of times, especially from an organizational viewpoint, you do not want general purpose answers. You want answers that are very, very tailored and specific to the kind of organization that you're working with, or to that specific domain in which you are asking your questions. And this is a thing that sometimes they get wrong, depending again on how much training they have undergone. Safety, whether it is exposing our data to the outside world, that's one way of looking at it. And the other way is because of the inherent bias in the training data itself, this whole option of generating sometimes harmful, very biased, wrong kind of content, that also poses a huge issue. And I'd say again, the really two big issues that kind of pop up are, one, the entire training data itself being out of date. A lot of times they claim that the complete data set, like in a lot of completeness, that way they end at probably end of 2022. So very recent issues, if you go ahead and ask for, yeah, the latest versions are doing a decent job. Sometimes they do get very current affairs a little wrong, because that's still not part of their data sets, unless they're once again integrating it back with some sort of a search engine. Yeah, this whole aspect of them extrapolating, or in simple words, making up answers when they do not have the actual facts available to them. um, and because of this whole concept of hallucinations, one, they do present a lot of false information, which is definitely a huge problem. Sometimes they do a lot of out of date or generic information. You might be asking for something very specific and they come back with a very general purpose answer that sounds good, but it actually is not the case a lot of times. How are they building their response? All of us are aware, majority of the data on internet, it's either biased, there's lots of errors in the data. Nobody's really checking for the accuracy or veracity of the data sets, the training data sets itself. So you train your systems on non-authoritative, very wrong kind of data, let us say, then your responses are also bound to be a little inaccurate. And the context and also the kind of terms that we use, something as simple as can I get a refund, if you ask 10 different users to put in that prompt, they might be using very, very different kinds of words to ask that exact same question. But if it is a human representative on the other end, irrespective of the way that question has been framed, also because they understand a lot of context, it's easy for us to pick up on the exact meaning. But sometimes use this terminology confusion can really throw those LLMs off and lead to very inaccurate results. We have some very well-known cases. These are probably not the important ones. I would say more the fun ones, where people keep looking at ways of trying to jailbreak a lot of these LLMs. Things like how many R's in strawberry. A lot of those models got it wrong for a really long time. Why are there two M's in weather? And it says, it is sure that there are two M's in weather because it is seen that quite a lot of times. This is again one term that you'll find a lot in literature. Simple terms that really throw it off. Solid gold magic card. The first time this was typed in, it gave the meaning of the word distribute. For some reason, when it did that whole tokenization and embedding, it looked similar to the word distribute for the LLM itself, which looks like a very silly problem for us. But yeah, very major issue in terms of what is going wrong when it is creating those embeddings and trying to get back those responses for us. More pertinent kind of a problem, this example probably I would say is like a couple of months old, where someone went to the chatbot and asked, like their bereavement policies, will I get a flight discount because I'm traveling because someone in the family like died? And the response was coming back from their chatbot, which said, yes, you can retroactively go back, ask them for a discount, you'll get like close to a 40% discount. So this person went ahead, booked tickets, and then later on went and asked for the discount. It turned out that the chatbot actually created a general purpose response based on general internet data, but not from specific Air Canada policies, and they didn't actually have a policy for a retroactive settlement of those kind of issues. And so this case went to court, and they said, because it is your chatbot, you are forced to honor whatever offer your chatbot has made. And again, the biggest problem here was these chatbots were making use of general purpose knowledge to answer back, instead of sticking to very specific policies that are only available or pertinent to Air Canada itself. This is the place where rags can come in and make huge amounts of difference, or really up that quality and the accuracy of the responses. So now our whole intent is, how can we build more contextually relevant information, so that we can be sure that this output actually matches in intent and in accuracy levels to the exact kind of question that the user is asking. So to be able to do this, that whole the term augment itself, you're trying to somehow improve on the capabilities of your already existing LLMs by informing them, giving them a lot of relevant and additional information, so that it knows how to create a response. But if you can also show it some more additional relevant specific information, the quality of the response, you will be guaranteed that it is a lot better and it actually meets the user's needs. Very simple analogy again. Let's say you're like in a bookshop or a library, or for that matter even a very huge supermarket. You're looking for something specific, you have to do it by yourself. Even like personally, some of us who don't prefer asking for directions, there's no need now anymore, but you did kind of go over and over and maybe spend a lot of time getting there, versus you actually go up to the librarian and say, I'm looking for this specific category, and they show you, these are the set of files where, let's say, psychology books are stacked. That really narrows down your search, improves your efficiency, narrows down on the time, and now you can go to that exact stack or the rack where you might find those books. In some places they might actually go pick up the book for you. So this is the kind of additional assistance that we are looking for. Instead of you directly going and asking a question to the LLM itself, there is some additional input information that comes in terms of picking up a lot of relevant documents. This is also fed in along with your prompt. This architecture, actually this picture makes that a lot more clearer. The original style of asking would be, you have your question, you directly pose it to the LLM based on its own pre-training and transfer training. It is able to come back with a response for you. But now, when you are using this augmentation, or you also have this RAG component as part of your pipeline, first, based on your question, instead of directly going to the LLM, this question is used for carrying out a much more localized, specific kind of a semantic search. So over here, it now has access to this additional data that is very, I'd say, enterprise specific or organization specific. This is also one very good advantage that RAGs bring in. A lot of times, especially organizations, wouldn't want their proprietary information to be shown to outside LLMs. Even if you're using, let's say, GitHub Copilot, you would want to use your own enterprise version instead of the regular public variant as such. So when you're carrying out this semantic search, these RAG pipelines have access to a lot of internal data. And the beauty of it is, you could be increasing on your internal database almost on a regular basis. It could be on a daily basis too. The more and more data you generate, maybe from your warehouses, or the kind of documentation that is available to you, you might be like really piggybacking on whatever content is available to you at a very fast pace. Basically, it means your information is up to date. So now you're doing this additional semantic search on your own internal database, picking up what is really important to be able to answer this question. This is once again converted into that similar kind of an embedding. If you go back, to those stage 1 and 2 of our LLM, we were talking about the kind of word embeddings that are created. So in a similar fashion, from your internal databases, there are these embeddings that are created which become part of a vector database. So now when your LLM gets its prompt, it gets the prompt that the user asked, plus a lot of this relevant and very localized specific information from the vector database itself. So it's getting basically 2 sets of inputs now. It already knows how to deal, or how to generate responses in a general purpose manner, but now it also has access to this really specific information. So think of it as like your own very personalized research assistant, or think of it as some expert who's sitting in between giving you additional inputs. So these additional inputs plus all the original training that the LLM has gone through make it really good at creating that kind of very customized response that you want, and that is what is shown back to the client itself. So I'd say, stages 2 and 3 is where a lot of additional work gets done by making use of the whole RAG architecture itself. So in terms of, the actual work that happens again behind the scenes, the retrieval process itself, in terms of pulling out what is needed, this is a little similar maybe, to the kind of search engine queries that we're used to. So we are now talking mostly about how information retrieval happens. So you put in a query, and then you go ahead and you pick up the set of documents that are really important to answer this specific query. Again, if we think back, to that Air Canada kind of an example, any organization for that matter, it might definitely have, a lot of internal literature. What are the return policies, or what are certain areas? How can, customers probably get like a lot of additional support? If it is like a e-commerce platform, what are their refund policies? What are their shipping policies? And those might change a lot based on the kind of product, based on the kind of customer, based on, the order value. So there might be a lot of intricate information involved in there. So now, based on my query, first the necessary set of documents are retrieved, and then these are once again ranked based on how relevant they are to the kind of question being asked. Supposing I say, how long will it take you to ship for like maybe, out of country, like a very really far off place? This is very different from asking a general purpose one on what are like, your just essential shipping policies as such. So among all the information, also, this kind of ranking that probably a lot of these search engines do in terms of ranking them based on their relevance to the query, and then finally going ahead and then creating, um, or I'd say fashioning this output into a form that your LLM can understand. So these once again need to become part of a vector database. They have to be embedded once again in a model which your LLM can make sense of. So this would be at the very initial stage before your prompt even gets into the LLM itself, one additional layer of work that comes in. Now, when it comes to the generation stage from the LLM itself, the original query that the user has asked, along with whatever output that was generated in that previous retrieval phase, all of these are encoded and sent to your LLM model. And again, they make use of attention mechanisms, the whole, transformer architectures and attention based mechanisms to pull out all the relevant information. And now the response that is being created is going to be very, very customized based on this additional input that has been sent into the LLM itself. And creating a very relevant and high quality response based on the actual input query happens. One thing you can be sure of is, at least, it won't give you inaccurate responses now, because it definitely has access to a lot of more relevant internal information about the organization itself. I'll go to that link in a little while, but yeah, in terms of general purpose use cases, let's look at time. Okay, all right. Customer support and service is one area where, there are like massive benefits from making use of RAGs, virtual assistants and chatbots. Instead of giving you again general purpose information, you can give very contextually relevant, accurate information that is tailored and customized according to the internal policies of whatever organization that is actually employing these kind of chatbots. The most pertinent information and very comprehensive kind of response. One, you can be assured of better accuracy, definitely a lot more customer satisfaction, because now you're not giving them inaccurate, you're also not giving them very ordinary information that they get back from a regular chatbot or a regular LLM, but instead it's almost like, someone from the organization is creating the response who has a lot of background knowledge. this will definitely improve efficiency. If you can give me exact information of what, let's say, Walmart's policies are, and not give me general purpose information, obviously my queries are going to be handled in a much quicker fashion, in a shorter span of time. Healthcare can actually benefit quite a lot from making use of LLMs that have been augmented with RAGs, because a lot of times when they are looking for specific information, let us assume, instead of going to again a general purpose LLM, you kind of enhance it with a RAG based system. It is already going to pick up a lot of relevant literature, relevant case studies, and treatment guidelines, so that you can really customize or tailor the kind of recommendations or the treatment plans based on that individual case details as such. Helps you with better decision making, again a saving of time, definitely more accurate information, helping you give enhanced patient care. E-learning is also one area where we can see very good benefits out of making use of RAGs. One, that whole concept of providing very personalized learning experiences based on each area. Supposing you're teaching, let us say, very advanced level botany for that matter, general response from an LLM might in fact be very accurate if you're looking for very in-depth kind of information. So now, again, you pick up a lot of very specific literature that goes into the RAG in the initial stages. And then, the kind of response that comes back from the LLM is going to be obviously of much better quality, and also meets the query requirements or your prompt requirements a lot more than what a regular LLM can do. So you can use this, to personalize the whole learning experience, either from a subject perspective or from a learner perspective as well. Also, because they have been trained on that internal data set, so to speak, they're also able to cite sources. This is where I got the information from. And that way it becomes easy for us also to, on the whole believability aspect, that the response that I'm getting back from the LLM is correct. Plus, these are the actual sources from where the lookup has actually happened. And as long as you can vouch for the accuracy of the sources, you can also be equally confident of the kind of responses that your system creates for you. The more accurate and relevant your material, obviously, more engagement, irrespective of the field. Similar to that, healthcare research and analysis, even legal professionals also one area who can benefit extremely, because especially, they will be forced to look up lots and lots of relevant case studies, relevant cases, where these kind of precedents happen. You don't want general purpose answers in these cases. So RAGs can be of a lot of benefit by picking up the exact kind of precedents, the very similar kind of case situations from massive amounts of literature, and be able to help legal professionals in narrowing down on the kind of case laws that they need to look at, or the kind of precedents that need to go into in terms of research. Does that mean RAGs really like solve all the problems that we saw with LLMs? No, they do come with their own set of issues. The way it looks like right now is we keep coming up with better solutions, and then we figure out they have like bigger problems, and then again there is this next wave of technology where there's like another solution being proposed. In terms of what they do, it seems straightforward, it kind of seems easy to understand, but actually building a RAG pipeline, integrating with the LLM, does take quite a lot of work. And there are quite a lot of inherent challenges involved. One, when we said we have access to this internal company wide database, it could be a lot of data in the form of PDFs, text. It could be maybe some sort of structured data coming from your RDBMSs. There could be a lot of unstructured data, again available to the organization. So how do you transform that into a fashion that you can actually feed into your LLM? Also, one term you will hear very frequently with RAGs is you will have to break it up into portions that are ingestible by your LLM. So what kind of chunking strategies are you going to follow? The scalability aspect of your pipeline itself. If you have like lots of data, how are you going to narrow down on the most important pieces of data? How are you going to break them up into smaller portions? Then how are you going to convert them into embeddings and then feed it into the LLM? So this is one area where a lot of work needs to be done. Pretty challenging depending on your own internal structures, depending on the size of the organization, depending on how their data essentially looks like. Retrieval also, based on the query, we are saying go do the semantic search, pull up the set of information that is needed. Again, think of maybe like a research assistant who has 6 months of experience versus someone who has 20 years of experience. The query might actually be so confusing that even your RAG might not be able to pull up the actual contextual information. That could be an issue. Although it picks up the right kind of information, is it able to really, format them properly and send them into that vectorized fashion, make them part of your internal vector databases? That is one other area where you're going to face a challenge. And then sometimes, again, even your internal databases within the organization also might be out to date, not really up to date, in which case, once again, you're looking at this problem of slightly out of date kind of responses coming back. And there are all these technical solutions, once again, that you will have to implement: multi-document agents, or being able to create very efficient knowledge graph systems that will be able to capture the actual context behind the query itself. There will be a set of challenges, once again, even in the generation stage. How quickly, we are now talking about having this added layer where it has to go query the internal database, create one more smaller subset of relevant documentation, convert that into a format which the LLM can use. All the time that it takes to create that response, then again, depending on the size of the organization and the size of databases, the amount of time it takes to create that kind of a response. Major aspect is data security. You want your information to be converted into those embeddings and then become input for the LLM, but at the same time, you should have enough guardrails in place so that this data doesn't kind of leak out of the pipeline. It doesn't become part of the overall training set of the LLM. You're just augmenting it, but not letting it see your original data. Also, domain understanding, if it's like a very specialized kind of an area in which you're trying to implement the RAG, this could become a challenge for the LLM upstream. So in concept, I would say, it looks kind of very straightforward and easy why you would want to go for retrieval, augmentation, and then generation, so that your LLM handles your tasks better. But in terms of the technical know-how, in terms of implementing it and overcoming a lot of challenges involved with it, it does take up quite a lot of time and effort. But they can definitely help us overcome a lot of those hallucination problems. And for sure, they can tailor the responses that actually serve an organization's interests. So I'm going to stop here. We'll just spend a few minutes on the question and answer. Before we do that, though, Raj has already mentioned, we have like that upcoming webinar on responsible AI, probably end of end of November. So yeah, those who are interested in understanding the ethical aspects to AI and how we can make better use of AI, this will be a very good topic where you can get a lot of understanding into those areas too. Thanks, everybody.
Thank you, Aparna. Before we are on time, so before people leave, I would request a favor from you all. If you could take a few seconds to fill an anonymous feedback, which helps us to continue to improve. I know the team, Aparna, takes a lot of effort to really put together this content, present it, and it's all free and shared with a lot of effort and kind of to the community. So we really appreciate how we can continue to build upon it. So we would really request, it's anonymous, none of your information is shared. So as frank, as honest, or as inputs you can provide, that would really appreciate, only make the community and everybody better. I've also posted the links for the upcoming, whether you're coming through Eventbrite or Meetup. So those links are available. I've also shared in the beginning a lot of resources, right from free training to the other Meetup groups. All of our things are posted in terms of recordings and past ones. And if you actually look for the way we have been approaching, we have been starting from very basics of even machine learning and then deep learning and generative and LLM and RAG and now kind of thing. If you think about it, this completes a very good structure of a flow of generative AI and a very series of topics which are well covered and documented. So I'm grateful that the team has been able to do that. And thank you, the team and Aparna, for today's points and comments. And thank you very much.